Just one second. So the experimental verification is nothing but I'll take uniform magnetic field. See that? What I will take? Uniform magnetic field. Where I will take means plane of the paper. Here the cross symbol indicates the magnetic field is perpendicular to the plane of the paper. How that? The cross symbol is actually this is uniform magnetic field. Here cross symbol indicates, see, uniform magnetic field. Here cross symbol indicates the magnetic field is perpendicular to the plane of the paper. Just I'll show that the diagram. Suppose we will take a paper. See. The paper, the magnetic field, uniform magnetic field will move to the paper. How that means into the, this is entering, this is out. How that the magnetic field, see that the magnetic field is perpendicular to the plane of the paper. That indicated here the cross line. The cross line indicate what is that? The magnetic field is perpendicular to the plane of the paper. Next, I will take a small rectangular loop. What is this? Small rectangular loop. The rectangular loop has two arms. One is AB, another one is CD. Here the arm CD is fixed, that is not movable. But the arm AB is movable. What is that? Movable. Now what I will do means the arm AB move towards the magnetic field or move out towards the right side of the magnetic field. See. Here the arm AB move towards the magnetic field. So what happened? The length of the rectangular loop increases. Not only length of the rectangular loop increases, the magnetic field also increases. See that? Before the original portion of the rectangular loop A, B, C, D, what are the magnetic field means? 1, 2, 3, 4, 5. When I change the position of the magnetic loop, what is the number of magnetic field increases means? 2, 6, 7. Before I increase the rectangular, the length of the magnetic loop, rectangular loop. What is that means? A, B, C, D. This is A dash, B dash. When after I change, after the length of the magnetic rectangular loop, A, B, C, D, then A dash, B dash, C, D. Isn't it? See the diagram? So here you will see one observation. What is that observation means? When the rectangular loop length increases, the magnetic field also increases. Not only magnetic field, the magnetic flux also increases. What is that? The magnetic flux. What increases? The magnetic flux increases. So according to Faraday law of electromagnetic induction, whenever there is change in magnetic flux, here before the magnetic flux is 5, after that the magnetic flux is changed, no. So whenever there is change in magnetic flux, an EMF, that means induced current, is produced, isn't it? From the definition of electromagnetic induction, induced current is produced. Due this induced current, according to the Lenz's law, the induced current oppose the, what they oppose means the increase in the magnetic plus, opposing the magnetic. How that opposing the magnetic flux? We'll see. The induced current produced, no, this induced current automatically produce another magnetic field. See, the circles are represented by the magnetic field. The magnetic field is produced by the induced current. How that magnetic field means the magnetic field is opposite to the magnetic field. This is the direction of the magnetic field produced by the induced current. This is the magnetic, this arrow mark is the direction of the magnetic field we are created. The induced current producing the magnetic field is the responsible to decreasing the or opposing the increasing magnetic field. Here, see that cause. What is the cause? Magnetic flux is the cause. What is the effect? Induced current. This induced current oppose the cause. What is the cause? Increasing the magnetic flux. So increasing the magnetic flux is going to decrease. How to decrease? Due to the what current? Induced current. The induced current create the, what they create means electric field. That electric field move, how they move means opposite to the beginning magnetic field. So we want to draw the diagram. Suppose I'll take a paper. It is not possible to take a paper. If you already diagram is there, no. This is beginning magnetic field. Now the induced current producing the magnetic field that travel. See that? The induced current producing the magnetic field is see, opposite to the direction of the magnetic field in the beginning. This is the reason when the induced current oppose the increasing magnetic flux. So next verification, experimental verification, Lenz's law. I will draw another diagram. So I'll take a uniform magnetic field. See that? So uniform magnetic field around rectangular loop. Rectangular loop A, B, C, D. In the first diagram, what we are seeing means the rectangular loop is increased, but here the rectangular loop length going to decrease. How to decrease means the original length of area of the rectangular loop is nothing but A, B, C, D. Now what I will do is I will move the one arm of the rectangular loop A, B towards the magnetic field or left to the magnetic field. See that? When I decrease the length of the, what is that, loop, the A dash, B dash, new area of the loop is A dash, B dash, C, D. So what happens? The number of magnetic fields are decreases. What is that? The magnetic field or magnetic flux decreases. So due to increases or decreases according to Faraday law of electromagnetic induction, the EMF is produced due to the EMF induced current produced, isn't it? Induced current produced. What produced? induced current produced according to Lenz's law. What that Lenz's law? Always the production of induced current oppose the decreasing the magnetic flux. No, here the magnetic flux decreases. That decreasing magnetic flux oppose the induced current. How that oppose? We will see that. Actually, if I'll take a paper. Before decreasing the rectangular loop, the magnetic field is move like that. When I was decreasing the magnetic area of the loop, that time the induced current is created. The induced current opposes the decreasing the magnetic field. The induced current also producing the magnetic field that represented by the circle. How that the direction of the induced current producing magnetic field means the same direction of the available magnetic field. This is the before we are decreasing the length of the rectangular loop, the magnetic field. When we have to reduce the producing the magnetic field, induced current producing the magnetic field, that direction also same. How that means the same direction. Due to the same direction, what happened means the decreasing magnetic flux going to stop. Maybe that is increases or constant. We will see that next experiment. So Lenz's law, mainly we have discussed two experimental verification. First experimental verification, we have taken uniform magnetic field. That uniform magnetic field is perpendicular to the plane of the paper. In that uniform magnetic field, we will keep a rectangular loop. In that rectangular loop, initially area is considered to be ABCD. Next, I want to increase the area of the loop. So new loop is A dash, B dash, C dash, D. New loop, if I increased, what happens means the magnetic flux also increases. Also, otherwise change. Due to change the magnetic flux, according to the Faraday law of electromagnetic induction, they produce induced current. According to Lenz's law, the induced current oppose the, what they oppose means cause. Here cause, what is that? Increase in the magnetic flux. We have discussed how that oppose. Next, second experimental verification, the same uniform magnetic field. I kept a rectangular loop. Now I want to reduce the length of the rectangular loop. That time what happens means the magnetic flux also decreases. When the magnetic flux decreases or increases according to the electromagnetic induction, they produced induced current. The induced current according to Lenz's law, they oppose the decreasing magnetic flux. How that opposing? We have discussed. See the diagram. This is what is that? Experimental verification. Suppose if you take a coil and magnet, another experimental verification also we will see. So you will get a clear idea, I hope. The Lenz's law, how the induced current oppose the cause. So experimental verification. Experimental verification. I'll take a coil. The coil is connected to the galvanometer. Positive negative galvanometer. Galvanometer needle 0, 1, 2, 3 goes on. 1, 2, 3. Next, I'll take a bar magnet. Small bar magnet, north pole and south pole. Bar magnet. slip, coil, here G indicates galvano. Now we will do the experiment, first diagram. How we will do the experiment means, when the magnet move towards the coil, what happens means the magnetic flux or magnetic lines linked with the coil. Here the magnetic lines linked with the coil is converted into magnetic flux. The magnetic flux will change. What is that? The magnetic flux will change. See that? These are the magnetic lines. When the magnetic lines entering or crossing the coil indicate magnetic flux, isn't it? Pi B. What is this? Pi B. How that the magnetic flux changes? Due to change, they produce what they produce. Induced current produces. What they produce? Induced current produces. That represented by I in anti-clockwise direction. So that induced current opposes the magnetic flux. How that oppose the magnetic flux? Here, when the magnetic lines crossing through the given coil means the coil behaves like a bar magnet. What is that? The coil behaves like a bar magnet. So the bar magnet means north and south pole. Coil also we will assume that north and south pole. See that the coil north pole and bar magnet north pole. We in the lower classes we are studied the same poles are repel, opposite poles are attraction. So here when the increasing magnetic flux is to be stopped. How to stop means see that north and north poles are repel. When the magnetic bar magnet move away from the coil. So move away from the coil means the magnetic lines crossing the given area is to be going to cut. That's why the electric current, that means induced current, oppose the increasing magnetic flux. Next, second diagram. I'll take a coil. The coil is connected to galvanometer, positive and negative, and I will take a bar magnet. In the first diagram, bar magnet north pole face to the coil. Second diagram, bar magnet south pole face to the coil. What is that? Face to the coil. So magnet produce magnetic lines. These magnetic lines crossing through the given coil, that is converted into the, how that converted means it is converted into the magnetic flux that is denoted by the phi B. Here when the magnetic flux changes, how it changes means the magnetic flux is decreases. Why it decreases? Either increases or decreases according to electromagnetic induction that produces the induced current. The direction of the induced current you need to find right hand thumb rule. One more question. Here also the direction of the induced current you have to find. The right hand thumb rule. This we already discussed in our previous chapter. Okay, right hand thumb rule. See here how to the induced current will decrease. We induced current oppose the decreasing magnetic field. Induced current. When the magnetic lines link with the coil becomes a bar magnet or magnet. See that here south and north pole, the bar magnet. See that the coil one end is north pole and bar magnet other end is south pole. In the lower classes we studied the opposite poles are, what is that? Attracted. So the magnet always attracted to the coil. When the magnet attracted means always the magnetic flux decrease is going to stop. This is the main function of induced current. The induced current we will find the means using Lenz's law. This is the experimental verification and conservation of energy. What is that? Conservation of energy. Lenz's law is also important one more question. Lenz's law is also known as conservation of energy. Conservation of energy. How that conservation of energy? We have discussed Lenz's law and two experimental verification, isn't it? One is ordinary magnetic field and rectangular loop. Another one is coil with the bar magnet. We have discussed. Use the discussion. We have to prove that conservation of energy. What the experimental verification intimate to us means that intimated to us when the magnet or the rectangular loop move to the magnetic field or away from the magnetic field or move inside the magnetic field, what happens means induced current, magnetic flux is changed. Going to change. When we move towards the magnetic field or move away from the magnet, what we have to move to or what is the thing? When the magnet or the coil move towards the magnetic field or rectangular move towards the magnetic field or move away from the magnetic field, what happens means magnetic flux going to change. Due to change in the magnetic flux, induced current produced. So according to conservation means it is converted, increases means decrease, one type of energy converted into another type. This is conservation, one form to another form. This is the, so Lenz's law is the conservation of energy. See that how that when the induced current produces, no, the induced current produces where the due to the induced current oppose the, what they oppose means increase or decrease the magnetic flux. How the magnetic flux produced due to the movement. Here how that oppose means here resisting. What is that? Resisting force acting on the magnet. Where the what force acting? Resisting force acting on the magnet. So how to remove the resisting force means we have to do some external work. We have to done some external work from the magnet and remove resisting force. The external work is the mechanical energy. What is that? The external what is the mechanical energy? The mechanical energy converted into electrical energy. And the electrical energy is converted into joule of heat. Joule's law of heating. So see that mechanical energy converted into electrical energy converted into Joule's law of heating effect. So conservation of Lenz's law is also known as conservation of energy. Suppose the Lenz's law, that means the induced current actually, according to Lenz's law, opposes the cause, isn't it? That only we discussed. If you imagine that is not oppose, that is help to the cause. Here, help to the cause means increase means increases. Increases means the magnetic flux increases, the induced current also, due to the effect of induced current also, try to here increases the magnetic flux, induced current.